Good morning, everyone. My name is Adam Carmi, and I am the CTO and co-founder of Applitools. We're a company that provides a cloud service for automated visual testing. And today I'll talk about how to effectively test responsive applications and websites, which is a problem that, at least in my experience, many teams struggle with. So this is going to be somewhat of an advanced session. We'll start by explaining what are responsive websites. Then we'll just jump directly into code and implement a complete test for github.com, which is a popular responsive website. And along the way, we'll share a lot of tips and best practices. And of course, there'll be time at the end to answer any questions that you may have. So what is a responsive website? If we look at the Wikipedia definition for responsive web design, we can see that it's an approach to web design aimed to provide an optimal viewing and interaction experience across a wide range of devices. But in order to understand what that really means, it's best to just take a look at a responsive website and see how it behaves. And we'll be looking at github.com. OK, so right now you can see github.com and how it is optimally laid out for a widescreen. We can see that at the top we have the navigation bar, and it shows the navigation items that allows us to access the important pages of the site. And above the fold, we have the most important thing of the website, which is the call to action for people to sign up. And we even have room for a sign-up form. If we scroll downwards, we can see more information. In this case, we see these boxes, that each containing an image and some text. And it is laid out in a single horizontal row because we have a lot of horizontal room available. Now, if we narrow the width of this web browser, you can see that as I narrow it, the boxes become smaller and smaller, the images become smaller, and there is less room for the text. And it continues to do so right up to the point where it doesn't look good anymore, but then the site switched layout and actually rearranged the boxes in two columns. And in each column, and in each box, you can see now that the image is big again, and there is plenty of room for the text. If we look at the top, you can see that the navigation bar is gone as well, because there's no room for the navigation items. But instead of that, we have the navigation menu button added here. If we click it, we can access the navigation items. And if we continue to narrow the width of the browser, you can see that eventually the sign-up form is gone because there's no room to show it. And if we look below the fold, you can see that the boxes are laid out in a single column because there's not enough horizontal space. So basically, this is a very, very good example for a responsive website that adjusts its layout to be optimal for whatever form factor that you throw at it. Now, just like we saw with github.com, it's also true for the majority of responsive web applications. The main factor that that determines the layout of the application or website is the width of the application, the width available to the application. And when we're talking about web application, that would be the inner width, actually the width of the viewport of the browser. And you can think of it as the width of the browser window minus the borders of the window itself. Now, the value of this property is the value of the width of the viewport is available to you in the inner width property of the window JSON object. And you can basically access that within your Selenium tests and use it. So enough with the slides. Let's start coding. As you all know, every test consists of interactions that simulate the user actions and provide input to the application on the test, and validations that actually get the output and verify that it is as expected. So right now, we're going to focus just on interactions, and we'll talk about validations later on in the talk. And I'm going to use C# for coding the tests. I'll use NUnit to organize the tests and execute them. And I'll be using Selenium to automate the browser. Now, the reason I chose C# is, first of all, because it's my favorite programming language, and I'm the speaker, so I get to choose. Second, there are hardly enough examples with testing with C#, and this is my small contribution. And third, it's very similar to Java, at least in the parts that I'll be using, so I'm sure that you will all be fine following what I do. OK, so let's begin. First of all, we need to add a new class to hold our test. Let's call it GitHub tests. And we'll be using an unit, so let's import a namespace. We'll also be using Selenium, so let's get it too. And we'll start with a Chrome browser. Great. Now we want to mark our class as actually being a test suite, so we do it in any unit by putting an attribute of a test fixture. We'll need a WebDriver, so let's add a field to hold it. And before each test runs, we would like to actually create an instance of the driver. And at the end of each test, we would like to tear it down. Awesome. So now we can write our test method. Let's call it test responsiveness. Yep, no typos here, OK. And what we'll do in our test is that we will visit, where is GitHub hiding? We will visit the home page, then and validate it. Then we'll click the personal navigation item and move to the personal page and validate it. And then we'll move to the open source page and validate it as well. That would be our test today. So we'll start by navigating to github.com. Then we'll need to locate the personal navigation item and click it. And we can see that it's basically a link, and it has the text personal. So for our purposes, we can just do a driver find element by link text. It's personal, and then we want to click it. And similarly, then we'll click the open source navigation item, which of course is identified similarly. So that would be open source, and we click it. Now, because we are testing the we want to test the responsiveness and the different layouts of the site, we don't want it to just the test to run on an arbitrary size. We want to control the size of the browser to control the width and therefore determine the layout. And so we would like to pass in a parameter to our test suite that would indicate the width. So let's say I want to pass it a 1,000 pixel wide browser, and I want it to be passed as a parameter. The way that I do it with NUnit is that I have to have a field to keep that value. I need to add a constructor that would take the parameter and set it to our field. And then, before starting each test, after opening the browser, we would like to set the size. Okay, so we'll just call driver manage window size. And we will use the width and some height. It doesn't matter which height. I use 600 pixels because that's what I want to use. It doesn't affect the layout, so it doesn't really matter. OK, so now we are ready to run our first test. Let's see what we get. OK, so Chrome browser is starting. Yep, and we just move between those two screens, and we're good to go. OK, so right now we are not doing any validations. We're just writing the interaction code, but we managed to do that. Let's try and run the test again, but this time on a narrower form factor. Let's try 800 pixels and see what we get. We see the resize to 800 pixels. But if we look at the test results, we can see that the test actually failed. Okay? Now, if we look at the result over here, okay, the screen resolution is not friendly at all, but we can see that we have a missing element. It cannot find the personal link. And if we look where it happens right here. If we look at the website and try to debug this and resize it to 800 pixel wide, which is approximately here, approximately here, then we can see that indeed the navigation button is missing, right? We cannot access it. On the other hand, we do have the navigation menu button. If we click it, we can access the link, okay? If I try to inspect the element over here, we can see that it's still, the locator is exactly the same. It's still a link. It's still identified with a personal homepage, personal text. And because of that, we can still reuse the same locator. It's just that it's hidden behind this menu over here. So if we want to have generic code that would actually work for both layouts, we can write a utility method that will do just that. It will look and see if this menu button exists. If it does, it will click it before clicking the navigation item that we want to click, right? If it doesn't exist, we can just click the element straight away. So let's see how we can locate this button over here. And you can see that it has a class. And the class is Octicon 3 bars. So let's use this to locate a button and write our utility method. Let's call it click nav item. It will take a locator, which is the nav item that we want to click. And first of all, we search for the menu button. We do it using our driver, of course, by class name, pass in the Octicon 3 bars identifier. And now we can check. If the menu button is displayed, then we need to click it. Otherwise, we don't need to do it. But we can do menu button click. And once we've clicked it, we know that the navigation item is available, so we can just do a driver, find element using the locator that we passed as argument, and click it. Fantastic. Now we can rewrite our test to do a click nav item, passing in the locator, and then the same here. And now we can try to run on both screen resolutions. So we started with 1,000 pixels, and we successfully navigated. And now the second one with 800. And you can see that we open the menu, click what we need to click, and manage to pass through them. So this is great because we have now generic test code that works for all layout of our website, right? But still, especially those of you who attended Marcus's talk yesterday morning can see that there is something terribly wrong with this test, something that is very bad. Any ideas what it is, the most obvious thing that is really bad about it? Sorry? Locators, and the fact specifically that they appear inside our tests, right? The problem here, of course, is that if I have 1,000 tests and that page would just change, I have 1,000 tests to update. What we would like to do is hide those implementation details at a single place so that we only have one place to fix it. And of course, we have a design pattern to do it, which is the page object. And I won't bore you with writing the whole thing. I'll just paste the page object version of this test, and we'll go over the source code itself. So basically, everything is the same except for the fact that we now have a base page object that has the common implementation details for all these different pages. And it has a constructor that will take user-friendly name, human-readable name for that page, and it will take the driver, and a third parameter that we'll discuss later on. And we have 3 pages, concrete pages, that extend this base page. The first one is the home page that will pass in home as the friendly name. The personal page, which will pass in personal, and the open source page, which will pass in open source. If we go back to our base page, you can see that it holds the common implementation to all these pages. We have the different link for the personal nav item, for the open source, and for the menu button, just like we defined them before. And it also has some common functionalities for all the different pages. For instance, in all of them, I can be able to go to the personal page. And this is implemented by calling our click nav item method that we just implemented before, passing in the personal locator, and then creating a personal page and returning it. Similarly, going to the open source page, passing by calling click nav item, passing in the open source locator, and returning the open source page. And the click nav item method is implemented exactly like it was before. We only have this new line here that we will talk about later on why we need it. But basically, we just rearrange the same test into page objects. And now, as an added bonus, our test looks much nicer and more readable. We start by creating a home page. After navigating to the home page, we create a page for it. We call go to personal page and get a personal page back. And then we call go to open source page and get the open source page back. OK, so very easy. And with this, we're basically done with our generic interaction code. Let's review some tips that relate to writing interaction code for responsive website that relate to what we just did. Now, the first tip suggests that you should detect page layout within the page object. Now, different pages will have different layouts and different layout transition rules. And because of that, the place where it makes sense to encode those rules is inside the page object of that page and outside of your test. For the same reason, we didn't want to have locators inside our tests. This way, if something would change with the layout transition rules, then we only have one place to correct it. If you do that, then you get for free the second advice, which is to be able to build browser and layout independent automation, just like we did now. We have a single piece of code that will work for all the different layouts, and it would look the same. The third tip suggests that you should avoid creating layout-specific page objects. Now, the upside of this should be clear. You simply have less page objects to write and maintain. And those of you who work on large-scale test automation projects know that maintaining dozens of page objects is not fun. Just think about what would happen if you have to multiply that number by 5. It would be too much. Now, the reason that you can use a single page object to represent all the different layout modes is because, like we saw with GitHub, for most responsive websites, the same elements and the same DOM is used for all the different layouts. You still have the same locators and the same elements. The only difference is their style, their position, whether or not they are visible, and some visual aspects, size, and other criteria. But the same elements are there, so you can reuse the implementation of the page object to work in all the different layouts, just like we did. The fourth tip suggests that you should avoid detecting the layout by using the inner width property. Now, although it is available to you and you could use it in your tests, and although the application itself is looking at this property to determine what layout to apply, you should prefer not to use it in your test, because if you do, you create a too much tight coupling between your page object and the page implementation itself. So for instance, if I would rely on the value of this property to figure out how to click the navigation item, then if a developer would decide to change the layout transition boundary by 1 pixel, my test will break unnecessarily. I will just have a breakage inside the page object. You won't be able to find an element, and I'll have to go and look and see what happened. On the other hand, the way that we solved it in a better way is that we looked at the DOM and figured out what layout is there. And this way, if someone would change the boundary transition point, then it would still work, because we would still see if the menu button is there or not, and it would still continue to work. So this is the recommended way to go. Now, OK, so now we know how to write perfect, amazing, and generic interaction code. Let's talk about validation. But how can we really validate that our site really provides an optimal viewing and interaction experience across a wide range of devices? And the answer is visual testing. And for those of you who don't know what that means, then it's a quality assurance activity aimed to verify that the UI appears correctly to the end user. Now, this goes beyond what you're used to do with Selenium and other traditional functional test automation tools, which basically test the functionality of the application through the UI. What visual test automation tools do is that they test how the UI itself looks like. They can make sure that each UI element appears in the right color, shape, position, and size, and that it doesn't override or hide or in any way overlaps any other UI element. Here you can see an example of a visual bug, in this case in the Twitter application. You can see that because of the narrow form factor of the device, there was no room for the text, for the notification text over here. And because of that, it overflowed downwards on top of the notification below it. So a visual test automation tool can easily detect this kind of bugs and automatically. Now, very briefly, the workflow of using a visual test automation tool is very simple, and it consists of 4 steps. In the first step, you drive the application under test with interaction code, just like we did now, and you get screenshots. In the second step, the tool compares the screenshots with baseline images. The baseline images define the expected appearance of the application at each point in the test. Okay? In the majority of cases, the baseline images are simply screenshots that were uploaded for validation on previous test runs and were found to be valid. In the third step, the tool generates a report that includes all the screenshots, all the baseline images, and any differences that were found. And lastly, a tester, a developer, a human being has to look at the report and decide for each change, if there were any changes, whether it is a bug, in which case he rejects the new screenshots and opens a bug, or if it was a valid change, he simply accepts the new screenshots, so they will become baseline images for subsequent test runs. Okay? Now, the first time you run a test, there is still no baseline. So the first time, save the screenshots as a baseline automatically, and then starting from the second run onwards, you always have a baseline to compare against. OK, so we've talked enough. Let's go back to code. And now we're going to add visual validation to our test using Applitools eyes. OK, so first we'll start off by importing the namespace. So that would be Applitools. The main class of the Applitools eyes SDK is called eyes, so let's add a field to hold it. And of course, before each test, we would like to create an instance of the eyes SDK and configure it. So what we can do is, first of all, create an instance and direct it to the eyes server that it is working against. OK, so that would be demo.applitools.com in this case. We need to provide our API key that identifies our account. OK, so that would be API key. It's hidden behind an environment variable. In this case, that would be the demo API key. We would also like to validate the entire pages at a time, not just the part that are visible through the viewport, right? So we can ask the eyes SDK to do this for us by setting force full page screenshots to true. And lastly, if you recall, every time we run our test, we have two tests running, right? Because one for each width. And we want those to be grouped together in the report. So we want to batch them together. So we create a batch object. And we'll call the batch responsive. Typo here. and we'll set it to our eyes instance. Great. Now we're ready to start the test, and we do this by calling eyes open. And first we pass in the driver. We pass in a name for the application that we're testing, and we'll call it GitHub. And, Gitbug, it's funny. And that's kind of a good name. And the name of the test, and with NUnit we get it by calling test context, current context, test name. The last parameter is the viewport size. And so it's exactly the same size that we set manually over here at the top. And we can now provide it to the eyes SDK, so it would set it for us. The big difference is that the eyes SDK will actually set the size of the window so that the size of the viewport will be the size that we are passing, as opposed to what we did ourselves, but that we set the size of the window to that size. Okay? And this is very important, and we'll talk about it very soon. I'll explain why. And of course, now that we've started the test, we need to tell the eyes server when we ended the test, so we can call eyes close after each test completes. And now we've done initializing the eyes object, and we can just add validation. So after we arrive to the home page, we can just call eyes check window. And we're done. We can pass in some description. Let's use the name of the home page here. And with this line of code, we just added 100% coverage, visual coverage for that page. We're completely covered. By doing this single line of code, we saved ourselves the need to write thousands of lines of code, validation code, and maintain them moving forward from now on. Similarly, when we move to the personal page, we validate it as well by adding very similar call to check window, this time with the personal page name as a description. And of course, we can do the same after the third page. Awesome. Now, we are almost done with validating our website. The only thing that's missing, if you recall, when we were running with an hour viewport, we had a menu opening up, right? We would also like to validate that state, because we might have some layout problems with the menu when it's open, right? We want to validate it as well. But we have a small problem, a challenge here. This UI state where the menu is open is specific to a certain layout. But we want to have generic tests, right? So how can we have a layout-specific validation point or checkpoint while still having a generic test that will work the same for all the tests? We could do the wrong thing and put the assertions inside the page object, but as you all, I hope you all know, is a very bad idea. The solution to this problem is actually to let the page object itself let us know, raise an event when it is going through an intermediate UI state. And this way, there is no assertion there, but the test itself can listen to that event and place an implicit checkpoint when that event happens. So let's do that. If you recall, when we looked at the base page, the constructor, here it is, took this parameter they called UI state change handler, which is basically a callback method. Now, whenever we click the nav item, if we open the menu over here by clicking it, we call fire UI state changed. Okay? And if we look at the implementation, you can see that basically it calls back the method that we provided in the constructor. So if you're running a test on a layout that doesn't have the menu opening up, this callback will not be called. If it is opening up, this callback will be called. And this allows us, within our test, to basically register a callback and say, I'm taking a description, and with this, I do a check window and passing in the description. And now I have a generic test that will have layout-specific validation points, right? And it will work the same for all layouts. So let's run it. And hopefully, the fact that the screen resolution here is very small, we will be able to set the viewport size. Let's see. Resize. Let's see if it succeeds. No, we didn't. OK. Let's see if at least the 800 will succeed. So set viewport size. If it cannot fit the width that we want, it will fail the test immediately. So it won't let you run in the viewport size that you don't want. But the screen resolution here is really bad. So luckily, I have test results ready from before. But basically, what we get is something like this. We can see that we have 2 tests running. And the first one would have 1,000 pixel wide viewport size. And if we drill down, we can see that it had 3 checkpoints. Okay? And the other has 800 pixel wide viewport. And if we look at that, you can see that it had 4 checkpoints, one for the menu opening up. Okay? And if we look at each of these steps, you can see that each checkpoint actually consists of 2 images. One is the baseline image, and one is the current image that we are comparing against it. So if there will be any difference between the current image and the baseline image, it will be picked up as a difference. So let's see how that would look like. If we had a little bit more time, we could have written many more tests, okay, that cover like different operating systems, different browsers, some devices as well. And in this case, we have 19 tests. All of them failed, covering 4 environments, 4 viewport sizes, and in total found 76 mismatches. And although it is very easy to see what's changed, to see that we have a difference here at the top, where at the header of the web application, and it's easy to zoom in and even accept the change or reject it very easily. Still, if we had 1,000 of these, this would be a bit overwhelming to look at one by one. So luckily, we can ask the tool to examine those differences for us and group together the similar ones. So we only need to look at the root causes of what changed. So it doesn't matter if we have 76 mismatches or 1,000, we only have 2 differences to look at. So let's assume that what we wanted to do is to change the GitHub logo from black to green. Okay? So if we zoom in on the first set of changes, we can see that in this case, exactly this thing happened. So the logo changed from black to green, which is what we expect. So we can just approve all these changes at once. If we look at the second one, we can see that in this case, the logo disappeared. So the developer did a mistake. He didn't do it correctly, and the logo disappeared altogether. And of course, this is a bug. So we can just reject all those screenshots. And with this, we're done maintaining. We can click Save here, and it will update the entire baseline for all those tests. Okay, so with features like that, you can run and scale your tests to running thousands and tens of thousands of tests every day, covering all the layouts of all your application pages and states in all the different devices and execution environments, and still without really increasing your maintenance overhead. OK, so let's review some tips related to validation. So the first tip suggests that you should set the viewport size rather than the browser window size. So we started out by setting the size on the browser window, and then we switched it to the eyes SDK. Now, the reason this is important is because when you're testing the layout of your application, you need to test the boundary cases when you switch from one layout to the other. So you have to be very accurate on setting the viewport size to that exact transition point. Now, it's very tricky to find the exact window size that would get the viewport size to where you need it to be. And moreover, this value is different for every operating system and browser, because different browser has different padding around the viewport, and different operating systems has different window width on the windows of their applications. So it's quite tricky to do. If you're interested to see how it happens, just go to GitHub, type in ApplyTools. All our SDKs are open source, so you can just search for the method set viewport size, and you can see how it's implemented. The second tip suggests that you should use page object callbacks to validate layout-specific UI states. That's exactly what we did, that the trick with the callback from the page object to let the test know that something visually changed, and the test can then assert it if it's needed. The third tip suggests that you should prefer full-page validations over component validations. There are two reasons for that. The first is that if you do full-page validations, you get more coverage. Of course, if you just check a single element, then everything around it is not covered, right? So you lose coverage. There could be bugs there. But the second reason, which is a bit counterintuitive, is that if you check the entire window, you basically have less maintenance and less work to do. The reason is that if you're focusing on specific elements, you need to get locators for those elements, and you need to maintain those locators whenever the page changes. If you just validate the entire window like we did, there are no locators, and when the page changes, you just need to look at the images and accept or reject them, just like we did now. So you don't need to go into code. The last tip suggests that you should focus on the lower layout boundaries in your tests. So you're all test professionals here. And I'm sure that you all know that when you need to test something that takes a range of values as input, and you cannot test each and every input value, then there are several techniques to how to choose the values that you work with, and one of them is the boundary cases. There's the lower boundary and the upper boundary, and the reason we focus on that, because this is where in the system itself you'll usually have the conditionals, and therefore the opportunity for bugs, right? The developer could go wrong there. But if you cannot test both boundaries and you have to choose just one, then when it comes to testing layout, always go for the lower bound. The reason is that the lower bound of each layout is the most crowded and ugly and condensed form of that layout, and there is less room for the elements, and because of that, there is more opportunity for having layout bugs. Okay? The other advantage is that if you have reports of your test showing screenshots of your application with the lower bounds of each layout mode, you actually make it clear to everyone how the application looks at its worst, because some users will see it that way. And it's important that everyone knows how it looks like, not how it looks like what is most beautiful, right? So just to show you that this tip is not theoretical, then I can show you, for instance, the Atlassian website. And you can see here the layout. Atlassian is the company behind Jira, by the way, if someone doesn't know that. But you can see how the navigation bar looks like on a narrow viewport size, and how it looks like on a wider screen, wider form factor, when there's room for all the navigation items. But right here on the lower bound of this layout, you can see. Here it is. So a layout bug here, it doesn't look, it's not centered as it should be. And so I guess that, I mean, in every second website that you look at and just try it out and just narrow the layout to the minimum bounds, you'll find errors like this. It's very easy to find. So with this, I concluded the talk. If you have any questions, I'll be happy to take them. Thank you very much.
Hey, and thank you for your talk. So I have a question about dynamic elements on the page, how that framework can handle that.
Sure. So there are plenty of ways to do that. The first way is that it is possible to, on the baseline images, to mark areas to be ignored. It is also possible to mark areas that are moving around and place the bounds where they are allowed to appear. So if they change or appear elsewhere, it breaks the test. It's also possible to focus on specific elements. So if the test is if the page is very dynamic, you can also focus on the parts that aren't, and that will work as well. But it's also possible to compare pages by layout, and this means that even if you have like a very dynamic portal with changing stories or text and images, it will still extract the layout of the page out of the screenshots and just compare and make sure that everything is laid out correctly. Of course, in that situation, if you'll have a typo all of a sudden or an image would be replaced, the tool won't let you know about that. But if something would overlap another thing, or a line would break, or an image would be missing, it would tell you that there's a layout problem.
OK, thank you.
Thank for your talk. Is it possible do not fail test? Just check layout, and if even it's is there some mismatches, just skip it and just go to the site and analyze it later.
Yes, definitely. So the ICE SDK, if by default, if it finds a difference, then the close method that I put at the teardown code will throw an exception that will fail the test, and the subject of the exception is the link to the report. So if you're running in Jenkins, it will automatically be listed. But there are overrides to ICE close that basically give you back a results object, and then you can check just programmatically if there's a failure, log it, not necessarily failing the test. And it also allows you access to download the screenshots and all the details of the test if you want to store it and build your own report. Okay. But the default is to fail. Yes?
Hi, thank you for your report. I have a question. Is there any opportunity to download to application the images which should be the basis?
Yes, of course. There is everything that the web application that I just shown you is doing and showing you. Everything is accessed through an API, and this API is available for everyone who has the right access keys to get. So you can get